Can you see my screen?
Yes, sir.
All right. So did anybody try to complete this proof? So what is so? I mean, nobody tried actually, is it? Anyway, I'm leaving that as it is. So if you don't try, I mean, it will be difficult to learn. Okay, so let me ask you a question. So suppose T1 and T2, let's say T1 Rn to Rm and T2 from Rn to Rk are two linear transformations. Suppose T1, the matrix representation of T1 with respect to the standard basis is A, and T2 with respect to the standard basis is B. So what is the matrix representation of T2 compose T1 with respect to the standard basis of Rn? Well, with respect to the standard basis of Rn and Rk. Yeah.
Just these two.
Right. So it is product, right? So so if you have not, if anybody have not done it, so do this thing. So this is very important. So this is purely linear algebra. Now we look at this star where the transformations are the derivative, right? So let's go back to chain rule. So let me just copy and paste there. Right. Now, can you tell me what will be the statement in terms of the matrix representation? Yeah. So the same thing. Now you have this one as a linear transformation. This is a linear transformation, and this is composition of two linear transformations. All right. So now the chain rule becomes when we look at the matrix representation the following, which is the matrix representation of T G compose A at A, right? With respect to the standard basis or whatever Rn it is the matrix representation of dg at fa times, this is also with respect to the standard basis, and this is also dfa with respect to the standard basis. Now we know what is this representation, right? So what is, let us look at the matrices. Matrices. So what is dfa with respect to the standard basis? What is it? See, from where to where? F is from Rn to Rm and G is from Rm to Rk. Right? So F is F1, F2, Fm. So what will be the matrix? Yeah.
n column m rows and del f by del xj, del fi by del xj as the
Right. So let me write it precisely. Let del F1 by del X1, del F1 by del X2, so on, del F1 by del Xn. Del Fm by del X1, del Fm by del X2, del Fm by del Xn. All right, at A, everything evaluated at A. So you might think this is very simple, but when what we are actually dealing with now will be important for the rest of the analysis and geometry courses. So, so this is extremely important. And so, what is dg at f of a, the matrix with respect to the standard basis? So, what is it?
Del GI del XJ calculated at FA.
Right. So del G. So G has how many component?
M cross K.
G has just K component, and this will be what? What will be the order of the matrix?
K cross M.
Ah, K cross M. Here you see F1 lies in the whole row, first row, you have only F1, right? You have only F1, and you dealt with Fm in each of the row, one FGS comes. So this is M cross N. So del G by, see here one can actually, so x1, x2, xn are the dummy variable. Here I can write x either way, x or y. So I'll look at the variable y actually. Y1 at f of a, the g1 del g1 by del y2 at f of a, del g1 by del ym at f of a. Similarly, here second column will be del g2 by del y1 at f of a, del g2 by del y2 f of a at f of a, del g2 by del ym at f of a, so on. And here del g last column, last row, g del gk by del y1 at f of a, del gk by del y2 at f of a, del gk by del ym at f of a. All right. Now in this way, we actually found what is the partial derivative of, so each of the entries here are the partial derivatives, right? So what we found, two matrices equal implies entry wise equal. So we actually found the partial derivatives of G compose F, each of the partial derivatives in terms of this. So this is very, very important. So, and let me write that the derivative of G compose F, right? G compose F at a, with respect to the standard basis as before. So del G1. So how many components will be here?
K cross N, I mean, the matrix.
Yeah, that is true, right? So G compose F will have how many components?
K cross N.
This is just the composition of two maps. It's not a matrix.
K
Matrix is
components.
K components. K components.
K components, right? So this is nothing but G1 of F, G1 composed with F, GK composed with F, right? This is nothing but this one. So this is not the definition. This is actually the thing, right? Do you see it? G compose F is nothing but G1 compose F, comma, G2 compose F, dot dot, comma, GK compose F. So here, del G1 compose F by del X1 at A, del G1 compose F by del X2 at A, del G1 compose F by del Xn at A, del G2 compose F by del X1 at A, del G2 compose F del X2 at A del G2 compose, yeah, this is 2, G2 compose F by del Xn at A del G K compose F by del X1 at A del G K compose F del X2 at A del G K compose F at by del Xn at A, right? Now we have this one, we have this one, right? So what we have is you multiply the matrices and you will get it. Yeah. So we just need to multiply the matrix multiplication and see what happens. So the point is, I mean, so this is a very simple question. You must have seen it in linear algebra. You know why this matrix multiplication is in such a complicated way? First row you multiply with first column and not entry wise.
They are supposed to represent linear equations, I guess. With the first time they came up, they were supposed to represent linear equations.
Right. So linear transformation, the composition of linear transformation, what should come out by the product of two matrices. That was the key. So, and that is the reason you get matrix multiplication in that way, not just entry wise product. Okay. In any case, so let us look at this matrix product, and we'll get some nice things, and those are those are very very important. So now look at this matrix and product. So this formula. So maybe let me just copy this part again. Yeah, put it right here. Now this should imply since all these things are written, so I can take copy and put it there. Is equal to, first we have the product of this one, product with this one, with this, right? So now if we try to get entry-wise equality, so what do we get? Let's look at the first entry. G1 compose F by del x1 at A. So what is it? Yeah, tell me what is it?
So we have del summation
Right.
del G1 by del Y I
Del.
or
Right.
times
So let's simplify
evaluated
here.
at f of a times
Right. Evaluated at f of a
this times
times.
del f I evaluated at a by del x1.
No, evaluated after. You will do evaluation after taking derivative. Okay.
Yeah, yeah.
Right. And what is this? Del
X1
xj by x1 at a. Right. So j from 1 to.
m.
Right. So this is, I mean, let me, of course, this function is good one, but let me put it in explicit form because this is what is going to be very, very important. So del g1 by del y1 at f of a times del f1 by del x1 at a plus del g2 del, right? Oh no, what happened? Yeah, no, that is fine. I only to take g1, right? Del g1 by del y2 at f of a times del f2 by del x1 at a plus del g1 by del ym at f of a times del fm by del x1 at a. Right, so a general term del gi compose f by del xj would be like summation, or let's say this one, put a different one, L del gi by del yj, similar thing at f of a, del fj by del xl at a. So what varies? So j varies from 1 to m. All right, is this clear? This is extremely important. You just look at the matrix product. If you forgot this formula, if you forget this formula, you just look at the matrix product and you deduce it. It might take time, but you'll get things correct. So do some hands-on computations here to get these things. So this is extremely important. All right. Okay, so a few examples. Just 1 minute. There are a few exercises, I would say. So this is the most of the things about chain rule, the theory about chain rule. Let's do a few computation. Let me see from this book. Okay, so first thing is something like, yeah. So let's like this. Let's look at the following. So example. So let's look at from R2. So here the map is theta goes to cos theta, comma sine theta. Okay, and here you have just f, any f, any nice f you take. So what you need is this, already you know differentiable. So consider this, where f from R2 to R is differentiable. Right, so this one you consider G. So now f compose G is a map from R to R, right? And this is also differentiable, also differentiable. So what is f compose G prime theta? So what is it? Yeah, compute it in your copies and tell me what it is.
Sir, G is theta to cos theta comma sin theta, but what is f?
F is just any function, differentiable function.
Okay, sir.
So you give in terms of partial derivatives of it.
So will it be minus sine theta del f del x
Mm-hmm.
plus cos theta del f del y?
Right. So what do you do? How did you do? Tell me.
I computed the two matrices.
Oh, you computed two matrices. You don't need to
Minus
go.
sine theta cos theta, and the other one was just del f del x del f del y.
Right.
It was
But
fast in this case.
you actually can look at this one, this formula. See here, f compose G is just G. G have just only one. G actually G1 comma G2. That is true. Uh, right. And f is uh, so here what we need to do? We have, see, f compose G. Here we had G compose f. Right. So in place of here it will be f and here G. So G has two components. So what you need to do is you get habituated to use this formula directly. Of course, I mean you can do this matrix multiplication and do it. So what is it? You have the first one, right? First one is a function of two variable. So you put del f by del x. first variable, and then what will come here at of course at g theta, and then what will come in the product? It will be the first component of g, which means del g1 by del theta, plus similarly del f by del y at g theta, del g2 by del theta. G is g1 comma g2, so this is actually g1 theta, and this is g2 theta. All right. Now what is it? This is del f by del x at g theta. So this part is also important at g theta, which means actually cos theta comma sin theta comma sin theta. So and this one is del g1 by del theta, which is minus sin theta. So minus comes here, sin theta comes here, plus del f by del y at cos theta comma sin theta times del g2 by del theta. G2 was sin theta, so derivative will be cos theta. So this will be cos theta. So for example, why did I calculate this general? Now you look at at let's say at 0, theta equal to 0. Now let us look at theta equal to 0, right? So g f compose g prime 0 is nothing but here del f by del x at 1 comma 0 times sine 0, which is 0, plus del f by del y at 1 comma 0 cos 0. So which means here this part goes away 0. So here del f by del y at 1 comma 0. All right. Yeah. So now you can put, let's say if you look at theta equal to pi by 2, you can evaluate pi by 2. You can evaluate this one similarly. So what will be this one at theta equal to pi by 2? Yeah, Soikat, can you tell me? Yeah, Soikat, are you there? Yeah, so this is the one problem with online class. Looks like, I mean, he's attending, but he's not actually. Okay, Sorin, can you tell me?
Yes, sir. It's minus del
Yeah.
f by del x
Del f by del x.
evaluated at 0, comma 1.
Right. Yeah.
And sine, it will be sine 1, so 1, and cos, I mean pi by 2, so that will be 0.
Right. So this one only, right?
Yeah.
Okay. So this is actually, I mean, this is good. I mean, you can use directly if using a chain rule. So get habituated to use this part. Okay, of course, if you are not comfortable, you can always use matrix and multiply it and get it done. But whenever you have I mean big things, then it will be difficult. Okay, so let us look at some interpretation, right? So let us look at the following. So consider this one. So yeah, so example, this is example 2. So we have considered the following thing, right? Suppose f is from R2 to R differentiable, and let's look at the set S to be collection of all x, y, fx, y, right? The graph, right? X, y is in R2, right? Collection of all this graph. Now here you can actually consider a curve, right? Now consider a curve on S. So how a curve on S will look like? Can you tell me a formula? A general thing. We want to curve. We want to consider a smooth curve on the surfaces. Let's say gamma. So gamma a curve will be from, let's say,
0, 1, 0, 1, 2. Yes.
right,
Continuous.
right. So let's say instead of 0, 1, I could consider let's say -1 to 1 to S. No, but the question is how this gamma t will look like. Gamma t will be,
The smooth line type in 3D.
yeah. So can you give a formula? Of course, not explicit formula. So it will be something like this.
Some x of t, comma y of t, f of
Right,
x of t.
right. The same thing, yes. Gt, ht, f of gt, comma ht. Because unless you have this one, so a curve going to 3 dimension, here you don't need this f, right? You don't need this f, g, h, and then let's say another one, k, kt. All these things, 3 would give you a curve in R3, but that might not lie in the surface or in the graph S. So for that, you need the third component to have this form. All right. Now question is, what is gamma prime 0? Yeah. Can you calculate and tell me? Yeah. See, the first component has no problem,
So
right?
it's g prime 0 and h prime 0.
Ah. The only thing is chain rule you need to use here, right? Yeah, right. So you what you get is what Satyik is telling is it is g prime 0, h prime 0, and
G prime 0 del f del x at g.
right. So del f by del x at
G of 0.
g of 0, comma h 0, right?
Yes.
and then
G prime 0
G prime 0 plus
plus del f del y
del f
at
del y
G0 H0
G0 H0
H prime 0.
H prime 0. Right, is it clear to everybody? So you have no problem for this component. It's gt, so you need to take the derivative, so it's g prime t, and then putting 0 you get g prime 0. Now here also you have ht, and then you want to take the derivative with respect to t. You don't have anything, which you use chain rule, so you just take the derivative h prime t and put t equal to 0, you get h prime t. Now here what you need to use, f is function of two variable and g and h are function of one variable. So here you need to use chain rule, right? So f of, so you have something like, let's say kt equal to f of gt comma ht. So this you have composition. F is one function and g comma h is another function. Now here you need to take the derivative k prime t. Now here you have to use this chain rule, so which is you can use this in this matrix formula GTHT. So instead of writing this matrix form with respect to standard, you just don't write. You identify that linear transformation with the matrix, and you consider this the product. This is the standard way people does. And then this is another one, gt comma ht. So this matrix representation, what will be the matrix representation here? G prime t comma h prime t, right? It will be a column vector. So this map gt comma ht, this is a map from R to R2, right? So derivative of this one will be 2 cross 1 matrix, right? Now this one is nothing but, here it is del f by del x at gt comma ht, del f by del y at gt comma ht, and then g prime t h prime t. So here you get g prime t times del f by del x at gt h comma ht plus h prime t del f by del y at gt comma ht. All right, so now this k prime, and then now we put k prime 0, which is g prime 0 del f by del x g0 h0 plus h prime 0 del f by del y z0 h0, right? So you have this gamma prime 0 is as this one, right? Yep. Is it clear? Now let us see what this represent, right? So this is, so kt, I wrote this one, so you have actually gamma prime 0 is equal to, so gamma prime 0 is equal to f prime 0 g prime 0, all right, sorry, g prime 0 h prime 0 and k prime 0. Now what this represent? So the question is what this represents. So let us look at. Let us try to draw the picture. So you have surface in R3, X, Y, Z, and suppose you have a surface. Something like that, a surface. Okay. Now at this point, so suppose this one is the curve. This one is the curve inside this. This is gamma t, right? And at 0, you have this one, right? And gamma prime t, for gamma t, gamma prime 0. So this is gamma 0, and gamma prime 0 is nothing but the tangent vector to it at gamma prime 0. So this is the vector gamma prime 0. So the tangent to the curve gamma t at t equal to 0. Right? So we have already looked at about the tangent line and tangent space. Now you see, this is how you get, and this is how you calculate what is the tangent vector corresponding to a curve, right? And this curve, this vector lies in the tangent space of the surface as well, right? So this is what it represents. So this will be extremely important when you go to geometry of curves and surfaces course, and you will see almost every time you have to use chain rule. So better be comfortable with it right now. All right. Any question here?
So if I had a different curve
Yeah.
passing through the same point, 0, 0,
Yeah.
and if it had the same velocities there,
Mm-hmm.
that means g prime and h prime are the same, then I would have got the same derivative back.
Right. So the what you said, velocity is just this vector gamma prime 0.
Yeah.
This is the velocity vector. So, but you can have a different curve. Let's say you might have a different curve, something like this, and the tangent here will be different. So this is again, this will be this. Suppose this is alpha t, and so this will be alpha prime 0. This vector. So this also will be a tangent to the curve alpha, but this will also lie on the tangent space of the surface. So the upshot is one can get the whole tangent space using curves. And chain rule plays an extremely important when you have a particular curve and you want to find the tangent along that direction. All right. Is it clear? Any more question here? Okay, since you have no questions, so I'll end the lecture here. But now I'll give some problems to solve right now, and you can tell me once you have solved. Somebody have solved. So some exercises. All right. So let me stop recording.